In a recent study that was conducted by Gartner and Flexera, it was found out that in companies with more than 1,000 employees, the minimum cost for cloud computing is $2.4 million, and it could go as high as $100 million every single year. And in small and medium companies, the minimum cost is usually around, or the average cost is around $600,000 and $1.2 million. Now, what if you can place yourself in a position of high efficiency and find a way to reduce this cost, maybe by half or even by 75% of the total cost, depending on what the company works on. Now, in this video, I'll be showing you how to leverage AWS services as our use case, and the data engineering section of that AWS section, where you have the data storage and data orchestration, how we leverage data engineering to save the cost in that area. Let's get into the architecture of the system to discuss, number one, the current modern way of doing things and orchestrating the data on the data lake, on your S3 bucket and the rest, and the modern way of implementing a cost-cutting algorithm or methodology without sacrificing efficiency. Let's get into the architecture and get started with that. Let's see how AWS services is going to be servicing our use case. Okay, we're going to start by having some data points, which is going to be our inputs here. So we have Apache Airflow, Python, Java, or even file upload being saving data or streaming data into our Bronze storage. Now in this Bronze storage, this is where our raw data is going to be sitting into. If you are familiar with the medallion architecture, this shouldn't be a stranger to you. So we call this the Bronze storage because this is where we are storing our storage, our raw files. It could also be called the staging layer if you like, but we call this Bronze storage or Bronze layer, whatever you call it. Now, once data gets in here, what happens is we're going to have AWS Glue crawler that is going to be crawling information from here and using that in AWS Glue to create data catalog for us so we can see tables and database on our AWS Glue. But the challenge is on AWS crawler, we have the maximum time, the minimum time of 5 minutes. So each services that is going to be running is going to be running every 5 minutes. So if you schedule your job to be running every 5 minutes, what if you have a use case? Like in our use case here, we have less than 5 minutes timeline for us to reprocess all of the information. Now, that's one downside to that. The second thing is you cannot trigger based on events that is happening directly. So the crawler is not wise enough for you to know that a new file has dropped into your Bronze storage, so let me process it again. No, it doesn't happen that way. But what happens is in our use case, we want to make sure that all events that are coming into our Bronze storage, as they are dropping, the crawler is picking it up and then the process continues, because we have some business process critical processes here. Okay, so that leads us from here, that leads us to implementing the AWS Lambda function here. This is what comes to our rescue, and in this case we have the Bronze storage. Now AWS Lambda is going to be listening for event that is dropping into our Bronze storage. So when any of these actors drop files into our Bronze storage, AWS Lambda listens for that event and triggers the crawler, which in turn is inside AWS Glue. And once that is done, it triggers it creates the database for us automatically, and the tables that are related to this Bronze storage definition. And this can be done for as many services on our Bronze layer as possible. Now, that solves our problem, isn't it? But the challenge is AWS Lambda charges by run. So if you run it one time, you get charged once. If you run it 1 million times, you get charged 1 million times. And this is dependent on the number of seconds that the function takes to run. Now, the problem is if you have enough money, that shouldn't be a problem. You can service that. But if you have a limited budget, that could be a big constraint on your business, or you're a startup that is trying to survive on a little thing. Okay, now once this is identified, we need to find a way to be more cost efficient without moving away from AWS services and still be able to use all of these services without challenge. And that is what leads us to the final architecture which we currently have here. In this final architecture, we have the same actors that are producing data from different sources. We really don't care about where they are producing data from, but once the data comes in, we are streaming into the Bron storage directly. Now the only difference is, instead of having the AWS services here, we're going to be having MinIO, which serves as more like a drop-in replacement for AWS services. Most of the services that are happening on AWS that are relating to the storage part being supported by MinIO. So we're going to be leveraging that. So we didn't really change so much on that part. The only thing is we just unplugged AWS Glue and the Lambda service from AWS and replugged in the AWS Lambda and the Kafka broker and the rest of the information, the rest of the architecture, which we are going to discuss shortly. We just plug those in. Now in our case, AWS Lambda, once the event comes into the Bron storage, this gets triggered, and once this triggers it goes into the KRaft mode, where we have the actions that are being performed. So we have our controllers and our brokers here, and each of these actions can be visualized on the control center. So we have the control center and we can visualize what is going on behind the scene. Now the schema registry is here to make sure that all the events that are being published to our controller and the broker here are sticking to a particular mode, so we don't have surprises. So maybe the structure changes for some reason, or there are bad actors changing data that is flowing into our system and it doesn't break it down. Schema registry enforces that and makes sure that all the data that is going into our Kafka is as structured as possible. Now once that is done, we now have the second layer of the actors, which is the Apache Spark and Apache Flink, which are the major actors in this case. I'll call them the major actors. Okay, so one of them, which could be drop-in replacement for each other, is going to be listening in streaming mode across listening to events that are coming into Kafka. So it could be Apache Spark or Apache Flink. Either of them could work in this case. Now, let's say we choose Apache Spark for the real-time streaming, the other part for batch streaming. So what happens is, once event comes into our Kafka, Apache Spark picks it up and processes it and writes it back to Kafka. One of them, the other part, will be listening in batch mode. So now we have the data that has been processed and is ready to be listened to or to be further processed, written back into a separate topic, and we can pick it up from there. And the batch processing exchanges information from the stream processing engine from there. So now each of them can be drop-in replacement for each other. So if you are using Apache Spark as our batch processing, it could write into all of these destination location. Or if you are using Apache Flink, like in this architecture, we are going to have all of them right as the sync. So Apache Flink is going to run this in batch mode and sends data into Elasticsearch, Slack, Cassandra, and then the silver and gold layer will be attended to as well. So that is the entire architecture of the system. So if you have a notification that is turned on Slack, you can easily get it. A new event has happened, and this is the whatever processing mode. So now the advantage of this is, now on the crawler side of things on AWS Glue, maybe 1 minute, 2 minutes, 3 minutes, depending on how long the job takes. It takes about roughly about 2 minutes to finish a simple job on the crawler. So you see this is way more faster because now we are detaching the Glue crawler provisioning and trying to access all of the services on AWS Cloud, and then trying to run the job itself, then producing the report and storing it somewhere. We're trying to detach that into a simple architecture in this case. Well, not too simple, into a different architecture, so where we can have all of this handled by ourselves. So yeah, if this sounds interesting, let's get into the coding section and let's get into it. In this section, we're going to go through the process when we implement it on AWS. And that includes setting up our crawler, the Glue crawler on AWS, and also the S3 buckets that will be used for this process. So let's start with that. So once we're done with that, we go over to the manual setup where we can replicate the same services that we're running on AWS services. Okay, so let's do that. So I'll just click on the S3 and we get started with that. And once the S3 loads, I'll create bucket. I'll call this code with you, and I'll just create that. Okay, so there's a bucket already, so I'll just use that bucket. There's no need to create a new one. I'll just use the create code with you. So in this code with you, there's no object, nothing is here in this folder or so in this bucket. So all I need to do is initially upload 1 or 2 files in here, so we can use that to demonstrate this entire process. Okay, so coming back here, I'll just add file, and in the data set I'll just use the data set for 2023-01. okay, and I'll just upload this. By the way, the data set and everything will be available in the description, so you can just go there and get the data set from yourself. Okay, and once this is done, the next thing we want to do is click on close, and we have this. So let's create a crawler to create a DB for us, and we can use that. So we could go to AWS Glue, and AWS Glue, you can get that by typing AWS Glue here, and you can do that, or you just if you have it handy, just get it open from there. So I'll start with the crawlers, and I'll create a new crawler. So clicking on create crawler, I'll call this taxi crawler. Now potentially what this will do for us is to create a database and the tables for us. Okay, so here if you don't have a database, I would recommend you create a database first, because if you go through the process, it's still going to ask you to create a database anyway. So let's create one. So I'll call this taxidb, and easily in AWS Glue on the left in your data catalog, you can see databases here, and you can use that to create the database. So once I create the DB, database name lowercase and no longer here should be taxidb. Okay, and I'll just create that. Once that is done, you can see the taxidb created there. I'll just go back here. In my data sources, we don't have the data maps to Glue tables already, so that is okay. So we need to select a data source where the data will be coming from. So here I'll select that, and I'll click on browse, so I can select code with you, and then in here that will be the source path. So I'll just select code with you, and inside the code with you, I think we should probably restructure that a little bit. So we just have code with you, and we have a folder, so it's easy to say, let's say taxi project. I'll call this taxi project in the folder, and I can move this into that. I'll just move, and that would be taxi project. Okay, choose destination and move. So the data is there, and we should be fine. Okay, yep. So I have taxi project. So if you go back here and inside code with you, I have taxi project. I can select that and choose that. Okay, once that is done, I crawl all subfolders, and that's okay, and add S3 data source. So right now we have S3 code with you taxi project. Good. So I'll just click on next. Then the IAM role that I'll be using, I'll just quickly create a new one. Here I'll call this taxi project. Okay, and once I have that, there's no need for lake formation or any security in this case, so I'll just click on next. Then for the database, I'll just select taxidb here, and that will be okay. So the rest is pretty much straightforward. We don't need to do any grouping or anything like that. Then for the frequency, this is what I was talking about. So you have hourly, weekly, or even custom. So in the custom, so you can schedule the minimum you can have in this case is 5 minutes. So I'll just leave it as on demand, so there is no need to do any scheduling when we can easily just run that. Okay, and I'll create a crawler that is ready for us to use. So easily, if I run this crawler, that should potentially give us access to the status of the crawler, and I think in about 1 minute 50 something seconds the crawler should be done. Okay, so in 55 seconds the process is done. Right now, if I do a refresh, you should see the number of tables affected on the left here. One sec, it's still coming up. You can see one table change, 0 partition. So if you go to the tables, if I click on the databases and I click on taxidb, you can see I have taxi project as the table name. So here, if I view the data, we should be able to see the content of the file that was uploaded. Okay, so there's no output location, so let's edit that. So in the settings, I'll just have I have this as my output, so I'll just change that. So let's change it to, do we have access to this folder? Yep, it's fine, we have access to that, and we can come back here and run this again, and you can see we have this nicely presented table for us and the content of that table. So you can see the vendor ID, time of pickup, drop off, and the other information that are relevant in this case. Good. So that means right now the entire process for the AWS Glue has been demonstrated as working. Okay, now but the challenge is for us to schedule this, we have a minimum of 5 minutes. Okay, so we don't have 5 minutes for each of the services to be running based on the schedule. So for us to do that, we need to reduce the timing to, let's say, every 2 minutes. So we know it's 55 seconds that the entire process takes. So 1 minute should be fine, but that may be too close. So let's say we use 2 minutes. Okay, and in that case, if we have 2 minutes, then it will not be the time will not be enough, because we have a lot of 2 minutes and 5 minutes before we get to the next schedule. So that's not what we want. What we want is, as the data is getting into our S3 bucket, we trigger that, and we can actually be reactive, maybe trigger the crawling process. So in the next 2 minutes, before the entire process continues, we run it again. Okay, or each time the record gets into the system, we keep running that. Okay, yeah, so that's what we want to achieve. So let's go back here. So we've potentially demonstrated this as working, and now the next thing will be to that will be taxidb. Okay, good. So yeah, the next thing will be to go back into our databases here, and in this table I'll just delete this table. Okay, I'll delete this, and if you check here, we don't have any table anymore. Okay, so now once that is done, we need to close this Athena. We are not using it anymore. Now there are 2 ways to go from here. We can do the linking from our S3 bucket, or we can go into Lambda, create a function, and do the linking from there. So regardless of whichever approach we take, the process is fairly simple and straightforward. So let me show you how to do that. So if I go to Lambda here and I select Lambda, I just open that in a new tab, and I create function, and I'll call this author from scratch. So I'll call this taxidb function. Now if you're using Node.js or any other supported runtimes, you can use that, but here I'll be selecting Python 3.9, so I'll be using that, and I'll be using the architecture of x86-64. Now you can use any of the Python version. Maybe you want to use the latest one, 3.12 or 3.11, but I'll be sticking to 3.9 in my case, so you can change that at any point in time. Good. Now it says we have execution role. So this is very important, because if you have a role, this basic Lambda permission does not have access to any other AWS services. So if you want it to have access to other AWS services that will be connecting to, you have to give it that permission. So in this case, we are going to need the S3 bucket permission, and we're also going to need the Glue permission as well. So those are the 2 permissions we're going to be needing. So let's quickly do that. I'm going to create a new basic Lambda permission like that, as it is. So we adjust that much later, and we don't need any of this here. So I'll just create function. Now what that means is it's going to create a new execution role which will be attached to this Lambda function. Okay, And here, this is the sample Lambda function that we have here. And if you look at the configuration, you can see we have the permissions here. So let's start from here. So the permissions that we have is taxidb function role 8 whatever here. So let's go into this permission and attach some policies into this. So I'll click on attach policies and I have S3 full access to this, so we can have access to the S3 buckets, and we have the glue as well, so we have the glue console full access. So those are the two things that we're going to be needing. Okay, now we have these two accesses that we can use, so we can close that up. Now if I do a refresh, we should have policies listed here, I believe. This is AWS Cloud Formation, so you can we have access to all AWS services, AWS Glue. And if you look at the S3, we have list all my buckets, get, put, and stuff like that. Good. So that means we have the right permission in this case. Good. Now the next thing will be to start coding the Lambda function. So by default, there is a sample Lambda code. When you run it, you just get hello world or something like that. But that's not what we need. What we really need is to be able to connect to our Lambda function, S3 buckets, right, using the Lambda function. And we can listen to events that is coming in from our S3. Okay, that's what we want to do basically. So going back to the code section here, you can see if you run this, it says hello from Lambda. So yeah, so once we have that, what we really want is to connect to our S3 bucket. So to do that, we have a simple function. We just leave this as it is. Because we are in AWS ecosystem, I'll cancel this. Because we are in the AWS ecosystem, we have access to the Boto3 by default, because this is a Python function that is inside the AWS ecosystem. So Boto3 is supported by default, so you don't need to specifically install that. Okay, so let's go back here and I'm just going to say import Boto3. Now if you want to get some documentation on how to use Boto3, you can just type in Boto3 documentation, not Leo, thank you, Boto3 Boto3 documentation. Okay, and you can see the AWS SDK for the documentation here, how to use it, how to use SCS, SQS, and all this. Even almost all the services that are supported by Boto3. Okay, you will see the documentation here, and you can also search in that case. Okay, so I'll just leave it at that. So now the next thing we want to do is to initialize the services we're going to be using. So we have basically, I'll say initialize AWS clients that we're going to be using. So we have glue, which is going to be boto3.clients clients, and we have the glue. And then for S3 that we're going to be using as well, we have boto3.client client, and that would be S3. Good. Now the two services are potentially connected because we're in the ecosystem of AWS, so it's fine. Now we can remove all of this. So the first thing we want to do is get the bucket name. So now to put that into context, when an activity happens in S3 bucket, so when you put something or you delete something, you move it, or whatever activity you perform, all these basic CRUD, create, read, update, and delete that we usually do, what happens is an event is generated. So if you have a consumer that is listening for this event or listening to them, you can easily just pick it up from there and do whatever you want with it. So it gives you the key name, the timestamp, the size, and so many other information that is going to be attached to that particular file. Okay, now if you want to do anything with it, you can do it, and that's what we're trying to leverage on in this case. Okay, so coming back here, we have a Lambda function. So once the event is generated, you have the event here and the context, which is where the data is coming from, maybe the S3 or something like that. But what we are particular about is this event in particular. So what we want to do is get the bucket name, and maybe file key, and yeah, bucket name and file key is fine, which is the name of the file. Okay, from the S3 event. Okay, so we just say bucket name, It's going to be events, and that would be records. By the way, in case you don't know how the structure looks like, you can see configure test event here, and if you do if you go here and you click on, you type in S3 here, S3 put, it's going to look like this. So it's going to look like S3 records, and you can see in the first event you see all this information, so you can extract any information you want based on the keys that is here. Okay, so in this case we're going to be getting the information from records, then from S3, then from object, maybe other information here as well, but yeah, you get the point. Okay, so that's what the structure looks like. Okay, so I have the records, so I'll get the first record in this case, and I have S3, then I get the bucket and the name. What am I doing? Yeah, name. Good. So that gives us records, S3, bucket, name. So if you check here again, you see records, S3, bucket, name. So this gives us the bucket's name. So if you want to get the key, you go to records, S3, object, key. Does that make sense? Yeah, I hope it does. So yeah, let's go back here and get the file key as well. The file key is going to be event. We have the records, then we have S3 as well, and we have object, and we have the key, just like we discussed. Good. So we have the bucket file name, the bucket name, and the file key. So basically you can play around with this particular bucket name and file key. So if you have multiple buckets or multiple file key and you want to limit the triggering of the process to some specific folder or to a specific key, you can do that. All you just have to do is check if the name is in the file key, and that will limit whatever execution that is going to happen. But in this case, we don't really need to limit anything, right? We just have the file key and the bucket name just to be able to show how you can, you know, leverage further activity from here. But as it is right now, we have access to the bucket name and file key. We are not going to use it. What we want to do is anytime a put event happens, which is a new record is put into that folder and that triggers an event, what that means is we want to trigger the crawler to pick up the activity from there. So yeah, so that's what we want to do basically. So going back here, I'm going to have the crawler name. So let's say specify the crawler name. I'll call this maybe glue crawler name, and I'll call this maybe crawler name, if I can only type crawler. And I'm going to have what's the name of the crawler again? Coming back here, we have taxi project. So the bucket name itself is code with you. That's the name of the bucket. So I'm going to have not the crawler name. The crawler name, sorry, I was checking the bucket. So coming back here, I have the crawler, and I have taxi crawler. So I'll just copy this, and in my Lambda function, I'll put that as my crawler name. Then easily I can start the glue crawler, and it's simple. The way you trigger it is quite simple. You just say, if there's any response, you just say glue.start crawler, and the name of the crawler is going to be crawler name, glue.start crawler. Okay, and I can just easily print maybe I'll just use the function the string formatting. I'll say glue crawler with the crawler name started successfully. Okay, and if there's any exception and he couldn't trigger it, so we just get the exception as E, and we just say glue crawler. Maybe I'll just say error starting glue crawler name. Okay, I'll just leave it at that. and I can just put in the error message as E. Okay, so I have error starting glue crawler. Okay, good. And I can just easily raise this exception. Okay, raise E. Good. Now, at this point, the function is done. All we just have to do is test it out and see if it is working as expected. And the easiest way to test it out is to use the simple test function. So that means you don't have to use the actual file to test it out. You can use the text event to check if everything is working just fine. And let's do that. So I'll just go back here, and I'll just go back here. And what I'll do is go into the configure test event again, and I'll select that. I'll call this put test event. Okay, and this will be private, nobody's sharing that. And in the template is going to be S3. I'll select S3 put. Okay, now in the content is going to be principal ID will be left as it is, source ID will be okay, S3 here, but the bucket name will change. What's the bucket name in our case? The bucket name is code with you, isn't it? So we just have code with you as the bucket name. The principal ID is fine, but the ARN is going to change as well to code with you. And if you're not sure of that, you can get the ARN by clicking on this code with you bucket. And in the properties, I believe you can see the ARN here. If you copy that and you come in here and paste it, just paste it in there. And finally, you have the object. So the object you want to test for is just to say test key. I'll say text. Maybe I'll just use the taxi test, and I'll say file name dot parquet. Let's call it that. The size is 1 MB. E tag and the rest is fine. So I'll just save this. Then I can just come back here and just run this test. And I'm saying hello from Lambda, of course, because we haven't deployed it. So it says changes not deployed, so I have to deploy that first. So upon deployment, if I test this again, I should be able to see the actual execution. And you can see it says error message, task timed out after 3.01 seconds. Now, this doesn't mean your task has failed. What it means is the execution time was 3 seconds, was set for 3 seconds, but the execution is taking longer than 3 seconds, so it's stopping that execution from continuing. So for you to fix that, you just need to extend the execution time. And the way to do that is to go back to the configuration here, and you see the timeout is here, and just in the general configuration, and I'll just increase this to 1 minute and 1 minute 0 seconds, and I'll save that. And I'll go back here, and in the Lambda function, I'll test this out again. Okay, so there's an error. It says crawler name with taxi crawler has already started. So what that means basically is in this crawler, if you check our taxi crawler, because we ran the 8 the last time, even though it was 3 seconds, it was still able to trigger it, but it wasn't using any of the services or any activity that we talked about. So what that means is in that 3 seconds, it was able to trigger it and recognize that it's a push request that came out from the S3 bucket. So yeah, so the invocation was complete, and it was able to trigger that, and it took 1 minute 27 seconds. So right now, nothing is changing in our table. If I refresh this, one table change, 0 partition, nothing is changing. Everything is as it was before. So what we just need to, let's check if there's anything that is changing, so I don't assume. Yeah, okay, don't forget we deleted that table name. So what that means is the execution recreated the table. Now going back here, so we are on the same page. If I click on proceed and we check what's the count size of the record in this table, in this particular DB and table, So we have 10 records here, right? If I just select count of star from here and I run this, that gives me 3 million records, right? So that means if any record is joining this, we have 3,066,766. That's the number of records that is there. Okay, so what that means is I'll just copy this and keep it somewhere safe here, so in case we want to refer to this much later. Now that the Lambda function has been created successfully, so we need to be able to tie this and to be able to recognize the events that are happening from a particular S3 bucket, and that will be the next line of action. So going back here, our function is fine, we've just tested that. So what we just have to do is go back to the configuration here. In this configuration, we are going to have the triggers. So the triggers is what do you want to use to trigger this function. So it could be any part of the AWS services, but in our case, we are using the S3 bucket. Okay, so what I'll do is click on the hash trigger, and in the source, I'll type in S3, and that will be from S3 bucket. So it's going to ask me which buckets. I'll select the code with you. The event type that I want to use is a put request, right? So that means if there's any addition to a new S3 bucket, I'll use the put event in there. Now, if you want to be more specific here, you can do that. So if I want to be specific in my case, I want to say any taxi project related event that will be going in here. So what that means is if I have additional project and additional folder here, and maybe that will be like a football project, for instance, and there's an event in football project, the event will still get triggered, but it will not do anything, because what that means is that particular activity was not tied to it. So event will be generated, but nobody is subscribing to it. So that means the Lambda function we are creating here in this trigger is simply for this taxi project. We don't have any suffixes, so that's fine. It could be CSV, Parquet, or any file, and I acknowledge this. So what this means is you don't use the same bucket for both input and output. You don't use that, and that is simply because if you use the same input and output, what that means is as the data is going in, the event will be generated. When you write back as the output, another event will be generated, and that will cause recursion. So it will be doing a recursive call till Jesus come. So that means the entire, if you have 100 million, in no time you will spend it over unless somebody cancels that particular function or the trigger. Yeah, so that's something you have to be very careful of and be aware that exists in the Lambda function. Okay, so I'll just click on add. Now the triggers has been added, so this is adding or connecting to the S3 code with you bucket. So if you check the S3 code with you bucket and you check the properties now, if you check the properties, you will see that in the trigger section, event notification section, there is a new event that has been added to that, and this is a Lambda function that is called the taxidb function. So that means this is now listening to event types of puts that is filtering on taxi project related event. Don't forget that filter is for that particular folder. So just in case you created one and you're expecting it to be still used by another, you have to remove that filter so it can be used across all the folders that exist in your bucket. Okay, now we've been able to successfully do this. Now let's test this out and see if everything is working as expected. In our taxi project, we have the 2023 January, so let's upload the February records into that. And don't forget, we have in our Athena, we have 3,066,766, right? Okay, so let's add a file to that, and we are getting the February 2023 now, and we are uploading that to the system. It takes a few seconds for this to be done. So we wait for it to be done. Okay, so now that it is done, we are expecting a trigger to be done, because right now we have a new record that has been generated. So let's check if we have been able to generate that. If you check our crawlers and you check our taxi crawler, if we do a refresh, do we have anything here? No. So why don't we have anything here? That's an interesting one. Let's check it out. So we have the taxi crawler. Okay, and if we come back here and we have taxi projects, let's check the crawlers again. I don't know why, but it should pick up. So it is not picking up. We need to understand why it is not picking up. Okay, so let's check our function again, and in the configuration we have a trigger here, and the trigger is we have a prefix of taxi project, unless the prefix was not right. So what I'm going to do basically is to edit this prefix and remove it from there. I'm not sure whether that's the problem, but let's see if that is if that's the problem. And what I'll do is delete this and re-upload it again. I'll just permanently delete that, and we will re-upload. Okay, re-uploading that. Okay, so it is done now, and hopefully this should trigger it this time around. Do we have it triggered? Nope. And in the function, is anything triggering this? The trigger is to this S3 bucket. Are we in the right S3 bucket? Yes, we are. And taxi project, yeah. So why is it not picking up? Do we have any reason why something like that wasn't picked up? And this was 5:46, so it actually got invoked by 5:46, because this is like 1 hour behind. So yeah, it got invoked, but for some reason it wasn't starting. So let's see if there's any error generated from there. So the duration was yeah, and there's error count. There's one error that was generated, and it's going to be interesting. So this took how many seconds? This is 5:47. Now that was the initial one that happened, so it's not picking this up. Why is that? Let's test this out again. Yeah, taxi crawler started successfully. And if we check the monitor, are we able to see the invocations here? Yeah, is that even triggering this in the first place? Okay, that triggered it, but it's not automatically triggered. That's another issue here. Okay, so what do we have in the taxi project here? Is this picking up? Let's see. So put all objects. Okay. So I think there's an issue here. So the create event is a little bit different. So if I put something, maybe var the SDK, I'm going to use the put request. But if I copy or upload something, that is different from put request. Okay, so if in this case the multi-part upload should be the right one to use. So what I'm going to do is tick this all object create event. I'm not going to go for the all object remover, restore, or whatever. So I'll just select the all object create event. Yeah, so I'll save that, and that was the reason why. So that means if I use the put request through API, that would automatically get flagged. If I do upload, it will get flagged as well. If I do what else? Yeah, any types of upload into the bucket, it gets upload and it gets flagged and the event gets created. Okay, so let's do another one. So right now the crawler is should be done, and you can see the crawler took 1 minute 22 seconds. So if you check Athena right now, we should have taxi project. It says table descriptor. I'll just do a refresh here. Taxi DB. Yeah, we have taxi project. I'll just preview this. It says the metadata for this district contains duplicate column. This query rank against and query ID. So there's an error with this table. What I'll do is just delete the table, taxi project. So I don't know why there was an error with that, but what I'm going to do is we'll just put a new record into that and see if we're able to pick it up and run it automatically. Okay, so going back here, I have to okay, let me just delete this and upload this again. Permanently delete. Okay, I'll just re-upload that, and that would be add files 302 upload. Okay, so the upload is done. We go back here, and hopefully we should get a trigger, because automatically right now we are listening to all put events, all created events, all create events. Yeah, so that's 17:58, and that was 2 or 3 minutes ago. And let's check our crawler. Is that triggered now? You can see the crawler is running, and if I do a refresh, and that was 31 seconds ago. So this is listening as it should be. It's listening for events that are getting created, whether it's through copy or upload or put request. Now so in this folder we are listening to the right events, and we are actually being able to trigger the crawler based on the event. So one thing we want to do is just to add the filter back, the initial filter that we removed. We add it back and we test it again. Okay, and let's see what this looks like once it is done. Taking longer time now because it's no longer a single file that is contending with. It's actually working with two files that has over 3 million records. Yeah, so it's 2 minutes now, and if we check this is done, I think if we refresh this, we should see the latest invocation and the status, hopefully. And let's see, recent invocation. You can see this happened about 2 minutes, exactly 2 minutes ago, which is good. So you can see the billing duration in milliseconds and the bills here. Yeah, so that is done. And finally, we just need to go back into the our function, and in the configuration, we just change the triggers again, just like we did before. And this is listening to objects created, all objects created events. So yeah, so I think this also means that you can listen for a particular activity. So let's say you have a web interface that people can upload from the UI, and that translates to the API in the backend server. But if somebody goes behind the scene and uploads a file manually, it might be interesting to have an event to say somebody has uploaded a file manually and it's not through the direct method of API. That might be a single use case to be able to track whoever uploaded that and the file name information and all the right properties of that file, including the login ID of that person. Okay. So in our case, we have the taxi project that we want to filter for, and we just save that. And finally, I'll just upload one more file. So I'll just upload this file, and that will be the match file. And we can use that to test and see if the system is automatically able to trigger or not. Okay, so the file upload is complete, and this is through the file upload. And if you check the crawlers now, if you do a refresh, you can see 6 seconds ago, after the file got created, this got triggered. So this means that our file will always be up to date. Our tables will always be up to date. So now if you look at our architecture, so in this architecture right now, we've demonstrated that we are able to do this part for the upload, but we still need to have these other systems that are uploading files into our S3 bucket. So as it stands right now, our bronze layer is getting files and it's triggering this based on the Lambda function. So the Lambda function is listening to the changes that happens on this bucket, and it's triggering this particular crawler, which in turn creates a table and database for us on AWS Cloud. Good. So that has achieved our what we set out to do in this particular section of the video. In the next video, we are going to be going into the details of the data lakehouse, and that includes this particular activity. Where we are going to set up the Minio section on Docker, and we are going to plug in, instead of AWS services here. We're going to plug in AWS Lambda events and the K-Raft setup with the control center schema registry and other activities that are on the on this particular architecture will be set up. So let's do that in the next video.